Hi everyone. In this video we'll go through as to what is a logarithm and the laws with respect to logarithms.
Now, what are logarithms? Why do we need logarithms? Right? Logarithm is nothing but the inverse of exponential. Inverse of exponential. So, what is exponential? Exponent is nothing but a power. Right? Suppose you have 2 to the power x. 2 to the power x. This x is called as the exponent. Right? Say, for example, we take 2 to the power 6 is 64. What does this mean? This means that 2 multiplied 6 times is 64. If I multiply 2 6 times, it becomes 64. Right? So this is nothing but exponential form. Right? So the reverse of this is logarithm. So logarithm will tell how many times should I multiply 2 to get 64. It's the reverse. Here I'm telling if I multiply 2 6 times, I will get 64. But here my question is how many times should I multiply 2 with itself so that I get 64. So I know 64. I know the number 2. How many times? This x represents number of times 2 should be multiplied to get 64. Right? This is what we call as logarithm. We call this 2 as the base. And we call 64 as any number, say y. Right? This x is nothing but the exponent or the power. Right? Exponent, power, index all mean the same. Right? So x is the exponent, 2 is the base.
And 64 is any number.
Now, if I have to write this in exponent form, how will I do this? That is, if I have to write it in this form, I'll have to take the base. That's what we did here. We'll have to take the base 2 and we'll have to have the power as x and it's equal to 64. This is how you write in exponent form. Now let's generalize this, right? Instead of 2, we can have any number, right? So instead of 2, we can put a and x is any power. And instead of 64, we say it is, say y, right? Just to generalize. So now this is in exponent form. This is an exponential form. Now if you have to write the same thing in logarithmic form, then we'll write first, let's write log, right? And we need to write the base, which is a here. This is the base equal to x. This is the exponent and y. So x will come to the other side, a will be the base, and then we have y, which is next to log. So basically, if a is any positive real number, a is any positive number. So in the example, we took 2, right? If a is any positive real number and y is equal to a to the power x, then x is called the logarithm of y to the base a, and it is denoted as x is equal to log of y to the base a. Now instead of a, we had taken 2, right? And 2 to the power x is equal to 64. So instead of y, we had taken 64. Now what should be x, right? What should be x? X should be 6. Only if x is 6, then we'll get 64. So in the logarithmic form, it would be x is equal to log of, that is you take this x, this is equal to, because we have to find the power. Ultimately, we have to find the power, right? Because we need to find how many times this particular number or the base needs to be multiplied to get this value. So x is the power. So x is equal to log of 64 and the base, the actual number which should be multiplied will be here, log 2. You'll be placing it as a subscript. And the way we read it as, we say that x is the logarithm of 64 to the base 2. So the technique here is, we'll have to take the power like this, x is equal to, take the power equal to, put log, put the number a as base and y.
You can remember this as power is equal to log to the base of the number. X is the power, a is the base, and y is the number. So this way we can remember power is equal to log to the base of the number.
Few more notes here. What is a to the power 0? A to the power 0 is equal to 1. Then how do we write it in logarithmic form? Right? If a to the power 0 is equal to 1, how do we write it in logarithmic form? This is our exponent. So 0 is equal to log base is a of 1. This is how we write. Basically, log a of 1 is 0. The other note is, what if a to the power 1 is equal to a? How do we write in logarithmic form? A to the power 1 is equal to a. So this exponent will come on the left hand side. 1 is equal to log of this base. This number will come as the base and then this value. This is how we write when we have a to the power 0 is equal to 1 and a to the power 1 is equal to a.
Let's go through logarithmic laws. There are 4 important laws of logarithms. The entire concept of logarithm is dependent on these 4 critical laws. Let's go through them one by one along with their proofs.
The first law is log of mn to the base a is log m to the base a plus log n to the base a. If you remember the laws of indices, the same formula, same method. If you remember, we said that a to the power of m into the a to the power n is equal to a to the power m plus n. Same thing here. If you have log mn, log m into n is equal to log m plus log n. Exactly like this. So whenever there is multiplication, you can split it and add. Right? You have m into n, so it becomes log m plus log n. Let's prove this. Let's assume that log m to the base a is x. Let's assume this. Right? So we'll have to write this in exponential form. How would we write? Just take this base, put x to the power, a to the power x is equal to this value m. Right? A to the power x is equal to m. Then we'll assume that log n to the base a is y. Right? Same thing. Instead of m, we'll take n and we'll equate it to y. So if I have to write this in exponential form, then it's going to be a to the power y, a to the power y is equal to n. Now, let's assume that log mn to the base a is z. Right? Now, again, we'll write it in exponent form. A to the power z is equal to this one, mn. Now, we'll take this last statement. A to the power z is equal to mn. Now, using this statement, we'll derive this particular law. A to the power z is equal to mn. Now, a to the power z, what is m? We assumed m as a to the power x. What is n? We assumed n as a to the power y. Now, based on theory of indices, if you have something like this, if you have the bases same, then you can add the powers, right? So, it's going to be a to the power x plus y. This is based on theory of indices. Now, since the bases are same, the powers or indices have to be same, which means z is equal to x plus y. And what is z? What is z? We had assumed z to be log of mn to the base a is equal to, what is x? Let's substitute for x. X is this one. Log of m to the base a, and y is log of n to the base a. So we have proved this law. So let's go to the second law. Second law is based on division. The first law was multiplication, where we had log m into n to the base a. Here we have log m by n, right? This is the only difference. This is m by n. Now, whenever you have m by n, you just have to subtract. Again, this is similar to theory of indices, right? In theory of indices, we had a to the power m by a to the power n is equal to a to the power m minus n. Same thing we'll do here. Log m by n is log m minus log n to the base a. So we'll assume, like in the earlier law, we'll assume that log m is equal to x, right? If log m is equal to x, then we can write it in exponent form. How will you write in exponent form? Take this base, take this as power, a to the power x. A to the power x is equal to m. Similarly, another one, right? A to the power y is equal to n. Then we'll assume z also. A to the power z is equal to m by n. So we make 3 assumptions here, right? Now we'll take the last one. A to the power z is equal to m by n. So using this statement, we'll have to derive this particular law. So what is a to the power z? What is m? We'll have to take the exponential form. M is a to the power x. N is a to the power y. Now, based on theory of indices, we'll have to apply this law. A to the power x minus y. This is nothing but a to the power z is equal to a to the power x minus y. Now, since the bases are same, the powers have to be same. So, this means z is equal to x minus y. Now, we will substitute z in the logarithmic form. Z is this one, log m by n to the base a is equal to x. What is x? Log m. Log m to the base a minus y. What is y? Y is log n, this one, log n to the base a. So, we have proved this particular law. Now, let's go to the third law. Third law states that log m to the power n, m to the power n to the base a is n log m, right? Just look at this. The power n, you multiply that power with this log m. Now, let's derive this. Let's assume that log m is equal to x. Now, you write this in the exponential form. Take a to the power x, this is power, a to the power x is equal to m. Now, you raise both the sides, you raise the power, raise power on both the sides. So m to the power n is equal to a to the power x, the whole power n. Both the sides you're putting n. So we have m to the power n is equal to a to the power x into n, right? So we'll have to write this in logarithmic form. So this is the base, right? This is the base and this is the power. So we'll have to say power is equal to logarithm of base and the number. This is easier way to remember. Power is equal to logarithm to the base of a number. So you can write it as power is x into n is equal to logarithm of base is a and number is m to the power n, right? So that's what we've written here. Logarithm of m to the power n with the base a is n into x. Now what is x? X is nothing but log m. X is log m. So we have proven this theorem. Log m to the power n is n log m. Now let's go to the fourth law. Fourth law is nothing but change of base. You have say some base here, which is n, right? What you can do is, you can write as log m to the base a, log n to the base a. Basically, you're using this base here, a is the base, and taking log m and log n, right? If you have a form like this, you can write it, you can change the base. If I have something like this, right? Log 2, 4. How can I write this? I can write this as log 4 by log 2, say to the base 10. Now we'll prove this. Let's assume that log m to the base n is equal to x. Now we'll write this in exponential form. Exponential form is like this. This is power n to the power x, n to the power x is equal to this value, is equal to m. Now we take logarithm on both sides, apply log on both sides. So it's going to be log m is equal to log n to the power x. We saw in the third law, if you have something like this, if you have a power here, we can write it as x log n based on the third law. Now we'll take x on one side, x is equal to log m by log n. So what is x? We had assumed x to be log m to the base n. So we substitute x here. Log m to the base n is equal to log m by log n. So we have proven this theorem. So let's summarize the logarithmic laws. Log of m into n is equal to log of m plus log of n. Log m by n is equal to log m minus log n. So when there is multiplication, you need to add. When there is division, you need to subtract. And third law is log of m to the power n is n log m. You'll have to multiply this power with log value. And the fourth law is change of base, right? This is change of base. Log m to the base n can be written as log m by log n to the base a, to the base a. So notice the change in bases here.
Also, we will have to remember as to how to convert to logarithmic form given an exponential form.
So we'll remember this particular technique. So we can write it like this. Power is equal to log to the base of that number. Let's take an example. 2 to the power x is equal to 64. Now, x is the power, right? So power is equal to x is equal to log, what is base? This is base, right? If this is the power, then this is the base. So log 2. Number, this is a number. So this is how we write in logarithmic form given exponential form.
With this, we have come to the end of this particular topic. Thanks for watching. Hope this video was useful.